Okay, in this video we're going to be finishing off the applications of logs and exponentials. I might as well finish off where exactly I was at the end of the last video. So we had to talk about transformations with this graph. So I think f of x, I'll just quickly write that down. F of x was ln to bracket x plus 3 on 2. Okay. And you just need to realise that when you are factorising these, you can use your log laws. And I'll just write it down here. You can split it up, because it's two times that other bracket. So you can use your log laws to break it into ln that first one and ln the second. All right, and yeah, I just find that that's probably an easy way. Certainly, I know that, yes, you can do this as a dilation of a half from the y-axis, and then you can say it's to the left by 3 on 2. I think a lot of students get confused and mixed up with the other dilations. So just for the guys that look at my videos, just realise that when we do this, this is normally what we do, okay? And this will just be 3 on 2 to the left, okay? And it'll just be ln2 upwards, okay? Whatever's at the back is what you have, okay? And yeah, those terms are okay. All right, let's finish this last couple of examples, okay? So what we've got here is really a function. It's a logarithm function. And it just says that, let's have a look, it's the amount of words that we're learning. Psychologists determined that the student learned 129 words after 20 minutes. So they're just giving us a value here. So what they're just basically saying is L of 20 minutes gives us amount of words, which is 129. Okay, so we can sub that into the equation. So we've got 129 equals 100 ln k times t. So t in this case is 20. Simplifying that down, just divide both sides by 100. You'll get 1.29 is equal to ln 20k. Then if you just take the e to both sides, so you could take e to both sides, or you could rewrite this as an exponential, whichever way you would like to do it. You would get e to the 1.29 equals 20k. So k is equal to e to the 1.29 over 20. All right, so just to explain that, so something I have explained, remember you can just rewrite that as a exponential, right? There's the base number, goes there. There's the logarithm, goes there. And there's the answer, goes here, okay? Or you can, like you've done in the very first example in the booklet, you can, do e's to both sides, I guess is what you could do. And that side just becomes e to whatever, it just becomes whatever's inside, which is 20k. And then on this side, you just got e to the 1.29. Okay. Now, we could use the I'm not going to show you how to use these on the calculator, but, once you've got the function, you just really, I would put it in the calculator. They are quite messy, some of these. So just put it in the calculator and you'd get an answer of 59.7. Just remember, these are discrete values, right? We probably haven't talked about that much. Discrete means that, you can't have learnt 30.6 words. So you really should round down in this case. So you got 59 words. I know one year in the exams, they were looking for the discrete answer. How long does it take for a student to learn 180? Well, we're just going to keep going with the calculator. So we're just letting L of t equal 180. Okay, so remember you could just graph that, which I would have done. Okay, have your graph, and then you graph 180 and then find the intersection. Okay, and you would have gotten t is equal to 33.3 minutes. So that's all on the calc. Actually, sorry, you don't even need to do it that way, do you? You could just do a x calc on your calculator, can't you? Okay. Yeah, so just put that the equation in the graph and then do shift G solve x calc, okay, because this is a y value given and we need to find the x value. Okay, find L dash t. So L of t equals 100 ln, and then you've got your big constant here in front of t. So just remember L dash t would be, keep the constant of 100 at the front, over e to the 1.29 over 20 times t. You'll find some books will approximate that value, the e to the 1.29 over 20. So I can't leave it like that. But we haven't finished. You've got to do the derivative now. So it's 1 over whatever's inside. and then you've got to times by the derivative of this. So you just think of it as constant times t. So you're just going to have the constant over here, which is e to the 1.29 over 20. Okay, last question. What is the rate that a student is learning up to 40 minutes? So you just need to realize it's almost like this question is just to wake you up to what's going on next. You're just working out the derivative value when x is 40. Okay, so if I was using my calculator, I'd put in maybe dy by dx, the second one, and then I'd do a y calc. So on the calculator, I'd do a y calc for dy by dx. Okay, and you can check your answer as well. We get 2.5 words per minute. All right. So I think I've shown enough of those. Just to keep going, there is another one. Now you just notice there's some really good stuff here for your investigation. Okay, this is for the investigation. Now you'll find that in the test on logarithms and exponentials, you might come across these. Okay, so really, you find the investigation we go in a lot more detail. But I guess you just need to realize in the test you've got a calculator, and it does tell you that if you've got this thing called a surge function, the maximum occurs at this t value, the inflection occurs at this t value. And like I said, we do have skills to actually find those key points already, okay? So I'm not sure you really need to go to too much detail about them, but they're the two key features of those graphs. The logistics function, again, it's got a y-intercept, it's got an inflection, and they call it a limiting value along here, like an asymptote. All right, and you could use technology to find values on those as well. All right, so we might just leave those because they actually ask you to do some proofs with them, okay, and we will do those proofs for the investigation. So we'll come back to them at another time. What I do want to do is just have a look at an example with one of those functions, okay. So if we just keep turning over, I've got a mouse, so I can just go a bit quicker. There we go. So this one here, even though you might not really realize it, it's like the second one, okay? So we went through it really fast, but they sort of look like this. They sort of have an asymptote at the top, and they have a limiting value, okay? So this type of function, we can just use technology for, okay? So we don't need to go into too much detail. We can actually do the first one algebraically, right? So the first question says, find the initial weight. Okay, so the initial weight, I guess that would be at time 0. Okay, so you could just sub that into that equation. You could look at the graph. Depends on how many marks it is, isn't it? So if we just make that 0 at the top, it's just e to the naught. So it's really 2.5 over 1 plus 95, right? Because it's 95 times e to the naught, which is 95 times 1. So it's just 95 there. Okay, so you're going to have 2.5 over 96. Okay, and that gives us an approximate value of 0.0260 grams. Okay, so the initial weight of these bacteria. So we've got some bacteria growing. This is why this sort of makes sense, this graph. Okay, so these are called logistics graphs because they stop. They sort of approach an asymptote. So maybe if we're talking about bacteria, maybe they run out of food. Maybe they can only certainly grow to a certain size, and then that's it. Okay, there's not enough food to go around really, and so there's only a certain population that can survive in there. So this is the amount of them. Okay, here is the amount, and this is time. All right. So what is the estimated weight of bacteria after 8 hours? Okay, so I would suggest putting it on your calculator, and we'll get an approximate value for that is 1.85 grams. Okay, what is the rate? So be careful with your rate questions. So as soon as I hear rate, we're talking about this guy, aren't we? All right. So remember, I feel like I want to show you, but I think you've done enough. Remember, you after you've done the graph, do dy by dx, okay, and then do a y calc for this one. Okay, so maybe I'll write that down after. So remember, go find dy by dx and y calc. Okay, you put in x equals 6. All right. Find b dash t. Okay, sure, I'll do that. So our b of t looks like, I'll just rewrite it with a negative indice. So I'm just, all that stuff that was on the bottom, I'm just going to put it in a really big bracket, all to the -1. So if we go B dash T, we actually just got a chain where really the -1 will just come out the front. So you got negative 2.5, 1 plus 95 e to the negative 0.7 t to the -2. The derivative of all this, well, that'll be a constant. So the derivative of 95e stuff is just 95e stuff. And then don't forget your chain, you've got to do the derivative of this guy at the top, which is negative 0.7. What does it tell us? What does B dash tell us? Well, we know it's a rate, don't we? I guess while we're talking in the context of this question, so if you think about your graph, you've got time, and here you've got the weight. So I'm just reading off my sheet. That's the weight. So what does that tell us? That's just, I guess that tells us that the rate of change in weight, let's be specific, grams of bacteria, I hope you can read my writing, over time. I'm just looking for some units there, some explanation, okay? So we're basically looking at how the weight is changing over time, okay? And that's it for the booklet here, okay? You've got another video on conjectures, but like I said, the proofs for the surge and logistics, what we might do is just leave them for now, and we'll just do them in the next part, which is investigations. Okay, thank you.